In part 3 of our lesson on solving right triangles, you're going to learn about angle of elevation and angle of depression. Angle of elevation is measured from the horizontal up. So this happens if you have an observer that is lower than the object being observed, say it's up here, then from the observer we would draw a horizontal line. We draw a line going to the object, and then the angle of elevation would be the angle between the horizontal and the line connecting the observer to the object being observed. Angle of depression is measured from horizontal down. So this is going to happen when the object being observed is lower than the observer. So maybe the observer is here and the object is down here. We draw a dotted horizontal line from the observer. Then here's the line connecting the observer to the object, and this angle would be the angle of depression. So in this first example, a pilot flies an airplane at an altitude of 10,000 feet. So let's just take that sentence. We know that altitude is always going to be a line that is perpendicular to the ground. So we can go ahead and draw in the altitude of the pilot, and we'll indicate that it is perpendicular to the ground. And we know that that altitude is 10,000 feet. So we can label that on our drawing. Next, we're told she sees the airport up ahead at an angle of depression of 36 degrees. Now we know that the airport would be on the ground somewhere, so we can make a point in our drawing and call it the airport. So to draw in the angle of depression, we know that definition is that you measure from the horizontal going downward. So now we'll draw in the line that represents the distance from the pilot to the airport. And then that means that this angle right here is the angle of depression, which is 36 degrees. Next, we're asked to find her air distance and ground distance to the airport. So her air distance is going to mean her distance through the air, so from the plane to the airport. So maybe we'll use A for air distance. Ground distance represents the distance along the ground that somebody walking underneath the plane would travel. So that would represent the distance from the point directly under the plane to the airport. So I'll use a G for ground distance. Now we know that we have a right triangle, and in any right triangle we're allowed to use SohCahToa. So we can make a note of that to ourselves. We have a right triangle, so we're going to be able to use SohCahToa. Now we have one length of a side in the triangle, but we don't have any angles labeled inside the triangle. But we can get an angle inside the triangle by noticing that the horizontal dotted line is going to be parallel to the ground. So if we think of it for a moment as two parallel lines being cut by a transversal, then we can also use a rule we know from our geometry class that says if we have parallel lines, then that means that the alternate interior angles will be equal to each other. So if this angle of depression is 36 degrees, then that means this angle inside the triangle is going to be 36 degrees. Now that we have an angle inside our triangle, we're going to be able to solve for the missing sides. So relative to the 36 degrees, we see that the 10,000 is the opposite leg, and the air distance is the hypotenuse. So if we're using opposite and hypotenuse, then that means we have to use the sine function. So we know that sine of 36 degrees is going to be 10,000 divided by A. A is in the denominator, so we're going to want to cross multiply it up to the left-hand side, and sine of 36 degrees will cross multiply down to the right-hand side. Make sure you show that algebra step. We're going to get A is equal to 10,000 divided by the sine of 36 degrees. Now we're ready to pick up our calculators and find out what A is. So we'll enter 10,000 divided by the sine of 36, and we don't have to put the degree symbol in since there's no subdivisions into minutes or seconds. Then we hit enter, and the problem asked us to round to the nearest foot, so we see we're going to get 17,013 feet. And that's the air distance from the plane to the airport. We're also asked to find the ground distance, and we see that relative to the 36 degrees, 10,000 is the opposite leg, G is the adjacent leg, so then that means we're going to be using tangent. So we know that tangent of 36 degrees is going to be equal to 10,000 divided by G. And as we just had to do a minute ago, the G is going to cross multiply up, the tangent 36 will cross multiply down, and we get that G is equal to 10,000 divided by the tangent of 36 degrees. And we head over to our calculator. We have 10,000 divided by the tangent of 36 degrees, hit enter, and rounded to the nearest foot, we see we're going to get 13,764. And that is the ground distance from directly beneath the plane to the airport. Now, since this is a word problem, we would want to state our answer in a sentence. So we would say something like, the pilot's air distance is 17,013 feet, and her ground distance is 13,764 feet. Word problems should always have a sentence for their final answer.